Alright, let's look at binomial theorem. On the binomial theorem, we shall look at binomial expansion and Pascal triangle. I remain your presenter, Dr. KK Ikena Stephen. In elementary algebra, the binomial theorem of binomial expansion describes the algebraic expansion of powers of a binomial. Binomial theorem of formula is given as a plus b raised power n equals to a raised power n plus n combination 1 times a raised power n minus 1 times b plus n combination 2 times a raised power n minus 2 times b raised power 2 plus n combination 3 times a raised power n minus 3 times b raised power 3 plus up to b raised power n, where n combination r is equals to n factorial over r factorial times n minus r factorial. In compact form, the binomial theorem or formula is given as a plus b all raised power n is equals to summation n combination k times a raised power n minus k times b raised power k, where k goes from 0 to n. Example 1. On the example 1, we look at example 1a. Expand a plus b raised power 5. So from binomial expansion, we're going to have that a raised power 5 plus 5 combination 1 times a raised power 4 times b plus 5 combination 2 times a raised power 3 times b raised power 2 plus 5 combination 3 times a raised power 2 times b raised power 3 plus 5 combination 4 times a b raised power 4 plus b raised power 5. Now 5 combination 1 is 5, 5 combination 2 is 10, 5 combination 3 is 10, 5 combination 4 is 5. And then we collect terms and simplify. Therefore, we have that a plus b all raised power 5 is equals to a raised power 5 plus 5a raised power 4b plus 10a raised power 3b squared plus 10a squared b raised power 3 plus 5ab raised power 4 plus b raised power 5. In example 1b, let's expand 2 plus 3x raised power 3. So from binomial expansion, we shall have that 2 raised power 3 plus 3 combination 1 times 2 raised power 2 times 3x plus 3 combination 2 times 2 times 3x raised power 2 plus 3x all raised power 3. Now 2 raised power 3 is 8, 3 combination 1 times 2 raised power 2 times 3x we give 36x, and 3 combination 2 times 2 times 3x raised power 2 we give 54x squared plus 3x all raised power 3 we give 27x raised power 3. Therefore 2 plus 3x raised power 3 equals to 8 plus 36 plus 54x squared plus 27x raised power 3. Now let's look at Pascal triangle. In mathematics, Pascal triangle is a triangular array of the binomial coefficients that arises in probability theory, combinatorics, and algebra. Now let's look at this Pascal triangle. The first entry we have 1, second entry we have 1 1, and the third entry we have 1 2 1. This 2 is gotten from the second entry, which is 1 plus 1, which we give 2. In fourth row, we're going to have 1. We're going to have 1 plus 2, 3. 2 plus 1, 3. And then bring down the 1. And from there, you follow the same procedure. We have the Pascal triangle. Also, for power of n equals to 0, n equals to 1, n equals to 2, up to n equals to 6, we have the same Pascal triangle. Now look at this Pascal triangle. We have the same Pascal triangle. We have 1 1 1 1 2 1 1 3 3 1 1 4 6 4 1 and so on and so forth. Now for power of n equals to 7, we have that the last term there is 1 7 21 35 35 21 7 and 1. For power of n equals to 8, we have the last term as 1 8 28 56 70 56 28 8 and 1. Now example 2. Let's expand x plus y raised by 6. So from binomial theorem, we're going to have that x plus y raised by 6 we give 6 combinations 0 times x is power 6 plus 6 combination 1 times x is power 5 times y plus 6 combination 2 times x is power 4 times y raised power 2 plus 6 combination 3 x cube y cube plus 6 combination 4 y squared y raised power 4 plus 6 combination 5 x y raised power 5 plus 6 combination 6 y raised power 6. Now we can see that the power of x decreases from 6 to 0, while the power of y increases from 0 to 6. Now simplifying, 6 combination 0 is 1, 6 combination 1 is 6, 6 combination 2 is given by 6 times 5 over 1 times 2. 6 combination 3 is given as 6 times 5 times 4 over 1 times 2 times 3. 6 combination 4 is given by 6 times 5 times 4 times 3 over 1 times 2 times 3 times 4. 6 combination 5 is given by 6. 6 combination 6 is given by 1. Hence, we're going to have that x plus y raised power 6 is equals to x is power 6 plus 6x is power 5y plus 15x is power 4 y raised power 2 plus 20x is power 3 y raised power 3 plus 15x squared y raised power 4 plus 6x y raised power 5 plus y raised power 6. Example 3. Now let's expand 2x plus y all raised power 4. From the compact form of binomial theorem, we have summation, combination 4 combination k times 2x raised power 4 minus k times y raised power k. K goes from 0 to 4. Now, when k is 0, we have 4 combination 0. When k is 1, we have 4 combination 1. When k is 2, we have 4 combination 2. When k is 3, we have 4 combination 3. When k is 4, we have 4 combination 4. Now simplifying and collecting like terms, we're going to have that 2x plus y raised power 4 gives 16x raised power 4 plus 32x raised power 3 y raised power 1 plus 24x squared y squared plus 8x y raised power 3 plus y raised power 4. Simplifying further, we have 16x raised power 4 plus 32x cube y plus 24x squared y squared plus 8xy cube plus y raised power 4. Example 4. Now let's expand 2x minus 3y raised power 4. Now we have that 2x minus 3y raised power 4 can be written as 2x plus times minus 3y all raised power 4. In compact form of binomial theorem, we're going to have summation 4 combination k times 2x raised power 4 minus k times minus 3y raised power k, where k goes from 0 to 4. Now when k is 0, we have 4 combination 0. When k is 1, we have 4 combination 1. When k is 2, we have 4 combination 2. When k is 3, we have 4 combination 3. When k is 4, we have 4 combination 4. Now simplifying, we're going to have 16x raised power 4 minus 96x raised to the power 3y plus 216x squared y squared minus 216x y cubed plus 81 y raised to the power 4. Finding terms of binomial expansion. In general, the k term of any binomial expansion can be expressed as k term equals to n combination k minus 1 times x raised to the power n minus k minus 1 times y raised to the power k minus 1. Example 5. Find the 10th term of the expansion x plus y raised to the power 3. But from the formula, the k term is given as n combination k minus 1 times x raised to the power n minus bracket k minus 1 times y raised to the power k minus 1. Now since n is 13, k is 10, we substitute, we're going to have that 10th term gives 13 combination 9 times x raised to the power 13 minus 9 times y raised to the power 9. Now 13 combination 9 is 13 factorial over 9 factorial times 4 factorial, then times x raised to the power 4 times y raised to the power 9. Now 13 factorial over 9 factorial divided by 4 factorial is equals to 715 times x raised to the power 4 y raised to the power 9. Finding coefficients of a binomial expansion. For instance, if you are given x raised to the power 2 plus 1 over x all raised to the power 10, and we're asked to find the coefficient of x raised to the power 5. Now we're going to apply the binomial theorem and expand. After expansion, we have that the desired term is 252 x raised to the power 5. Therefore, the coefficient of x raised to the power 5 is 252. Summary 1. Under summary 1, we're going to have that x plus a raised to the power n is equals to n combination k times x raised to the power k times a raised to the power n minus k, where k goes from 0 to n. Where sigma notation is used to sum all the terms in expansion from k equal to 0 to k equals to 1. Also, n equals to positive integer power of algebraic equation, and n combination k is read as n choose k. Summary 2. The binomial theorem of the form 1 plus x raised to the power n is equals to summation n combination k x raised to the power k. K goes from 0 to n, where n combination k is equals to n factorial over k factorial times n minus k factorial, and n is a positive integer. Note, there are n plus 1 terms. Summary 3. For the rational index, the formula is given by 1 plus n x plus n times n minus 1 over 2 factorial times x squared plus n times n minus 1 times n minus 2 divided by 3 factorial times x raised to the power 3 plus to infinity. Now there are steps in expanding this kind of expression 1 plus x raised to the power n. What are the steps? Step 1. Factorize if necessary to make the first term 1. 2. Substitute in the values of n and x. 3. Simplify each term. 4. Write the values of x for which the expansion is valid. The validity of this expansion is absolute value of x is less than 1. Equivalently, we have that the valid is minus 1 is less than x and x is less than 1. Example 7. Let's expand square root of 1 plus x. First, write in index form. Square root of 1 plus x is giving us 1 plus x raised power 1 over 2. Now use expansion with n equals to 1 over 2 and x replaced with x. So we substitute, we have 1 plus 1 over 2x plus 1 over 2 times minus 1 over 2 times x squared over 2 factorial plus half times minus half times minus 3 over 2 times x is power 3 over 3 factorial plus infinity. Now simplifying, we're going to have that square root of 1 plus x is 1 plus half x minus 1 over 8x squared plus 1 over 16x cubed plus to infinity. Now this expansion is infinite and it is valid for when absolute value of x is less than 1. Example 8. Let's expand 1 over 1 minus x. Also, writing in index form, we have that 1 over 1 minus x is equals to 1 minus x to the power minus 1. Here, use n to be minus 1 and x replaced with minus x. Now, substituting in the expansion previously shown, we're going to have that 1 minus x to the power minus 1 is equals to 1 plus minus 1 times minus x plus minus 1 minus times minus 2 times minus x all squared divided by 2 factorial plus minus 1 times minus 2 times minus 3 times minus x all raised by 3 divided by 3 factorial plus to infinity. Now adding to infinity, we are going to have 1 plus 1x plus 1x squared plus 1x squared plus 1x raised by 3 plus up to infinity. Adding and simplifying, we're going to have that 1 over 1 minus x equals to 1 plus x squared plus x raised by 3 plus infinity. This expansion is infinite and it is valid for absolute value of x less than 1. Thank you. Please follow my YouTube channel for more updates. Thank you very much.